Hello, in this video, we want to talk about Argand diagram and modulus of a complex number. What is Argand diagram? Argand diagram is a diagram that illustrates the position of the coordinate points or the coordinates of complex number in terms of the real and the imaginary part. What do I mean by this? Every complex number is expected to have a real part and the imaginary part. So the positioning or the marking of the coordinate of the x and the y axis on a plane of xy plane is called Argand diagram representation. So when you represent the positions of the coordinates of this x and y, on the Argand plane, that diagram is called Argand diagram. So let's look at an illustration. This is an example of what? Argand diagram. Now we have the x positive and we have the x negative here. We have y positive, we have the y negative. Along the x-axis, we have the real parts, okay? Along the y-axis, we have the imaginary part. Okay, that is why if we pick a complex number z, it's written as what? X plus I, y. A complex number z is written as what? X plus I, y. X here represents the real parts of the complex number, and y represents the what? Imaginary part of the complex number. So, Argand diagram basically shows the position of the coordinate of x and y along the Argand plane. So that's what we mean by Argand diagram. So now, when we now talk about, let's talk about the modulus of the modulus of a complex number. The modulus of a complex number. What do we mean by the modulus of a complex number? Modulus of a complex number. Now, the word modulus of a complex number simply means the length. So you can write modulus can be, it could be the length, it could be the magnitude, it could be the radius of a complex number. Now, what do I mean? Fine. Let's draw an Argand plane. Now, on the Argand plane here, like I've just explained, we have x plus here, we have x negative here, we have y negative here, we have y plus here. So if we have a complex number, z is equal to x plus iy, as I've just explained. Along this axis, we have the real part, and along the axis, we have the imaginary part. So now, if I want to represent, a complex number of the Argand plane now, suppose I'm given, let's say we are asked to find z is equals to 2 plus 3i. If I want to represent z is equals to 2 plus 3i on this Argand plane, now compare this z is equals to 2 plus 3i with z is equals to x plus iy. You see that the real part is x is equals to 2. That the real part is 2. Why the what? Comparing this, we have what? Y is the what? Is the imaginary part. So that means we want to look for a coordinate point of x, y, which means 2, 3. Okay? Now, and don't forget it is positive. We have plus x plus y. So now we come here, let's assume that this is 2. Let's say this is 1, this is 2. And the 3 now on the y. Let's say 0. 0 is the what? Is the origin. So let's say 1, 2, 3. So let's assume these are 3. So the meeting point of 2 and 3, is a coordinate point for this particular complex number. So we can call this A, that is 2, 3. All right. So that is the position of this particular complex number. Now, when we now talk about the modulus, what are we saying? Fine. I said the modulus could be what? The length, the magnitude, or the radius. Now, from here now, we have gotten this point. Now, that implies that our y, like I said, is 3, and our x is 2. So the meeting point, the point OA, the length OA now, is going to be what? It's going to be our modulus. It's going to be the modulus. So the modulus of z now, z will be what? Length OA. And if you look at it holistically, you will see that this has represented a triangle. So here we have a right angle triangle. Now, we have a right angle triangle and OA is the length. Definitely, using Pythagoras theorem, it will be what? X squared plus y squared. That is square root of what? X squared plus y squared. I hope you are following me. If I call this OA squared, how did I get x squared plus y squared? I can easily show us there. Let's discuss that quickly so that it will not appear as if we are jumping. Let me write that here. So OA, that's how we got this. OA squared, could be what? Equals to x squared plus y squared. Our x squared, distance from this point to this point is x. Distance from this point to this point is y. Okay, so find the square root of both sides. You have OA now is equal to square root of what? X squared plus y squared. Now, so the modulus of z now, the modulus of z, because this is the sign of modulus, we put this vertical strips there. Now, the square root of what? Our x, according to the given example, is 2 squared plus our y is 3 squared. So that implies what? The square root of what? 4 plus 9. So what is square root of 4 plus 9? That is square root of 13. So the modulus of z, as given here, is root 13. Don't forget I said the modulus is the length, is the magnitude, is the distance between this point, and this point. So that solves the problem of the modulus of a complex number. So let's illustrate more with examples. Let's illustrate more with examples. Let us illustrate more with examples. Now, let's find an example one. Example one. Example one. If z is equal to 1 plus I, mark, if z is equal to 1 plus I, mark the points 1, the first one, 1 plus z, 2, 1 over 1 plus z in the complex plane. We want to mark this point in the complex plane. How do we mark the point in the complex plane? Let's look at that. Now, if z is equal to solution, now z is given to be 1 plus I. So 1 plus z will be, remember z is given to be 1 plus I. So 1 plus z will be what? 1 plus, our z is 1 plus I. Okay, so 1 plus I. So that's what? 2 plus I. Okay, now 2 plus I is the value of 1 plus z. So how do we now mark this point, in the complex plane? Now these are complex plane, like I've shown before. Okay, don't forget, now you compare this plane, now this value with what? X plus IY. It's like saying that z is equal to what? X plus IY. So our x here now is 2, while our y is what? Our y is 1. The coefficient of I here is 1. So that means the what? The coordinate point, let's assume A, will now be what? 2, 1. So just come here. It is, both of them are positive. You have 2 here, and we have this, let's say 1 here. So the meeting point now of the two, is what? A into 2, 1. So that is how that is. Okay? I hope that's understood. Fine. Now suppose we are asked to find the modulus. You just apply the formula I taught you. Okay, let's do the second one. So now we have gotten that. We are going to do the other one here as well. So now the second one is 1 over 1 plus z. We have 1 over, what did we get for 1 plus z? That's 2 plus I. So, and we cannot leave it like this because this is irrational as a complex number. So now what? Rationalize by its conjugate. So that multiply what? Don't forget, I've taught you something about this before, because now you cannot leave it like this, just like a rational sum. So you make it what? This is irrational, you make it to be rational. Multiply by what? The complex, the conjugate of this. The complex conjugate of 2 plus I is what? 2 minus I. So everything over 2 minus I. Okay? Now, we have 2 minus I all over 2 times 2 is 4 plus I times minus I, that's minus I squared. Don't forget that. I've taught you that before. So now we have 2 minus I all over. Now, 4 minus, in complex number, minus I is equals to what? Minus I is equals to root 1. So, in complex number, root minus 1 is equals to I. So, I is equals to minus 1. And it's I squared. So, minus 1. Again, don't get it confused. I said in complex number, root minus 1 is equals to what? I. Okay? So, now when you square this root minus 1, now I square will be root minus 1 times root minus 1. Okay? And that's what? Minus 1. So in complex number, I square is minus 1. Don't forget that, please. So you have 2 minus I all over 4. Minus times minus is plus 1. So that gives us what? 2 minus I all over 5. Now, you can't leave it like this because you have to express it in form of what? In form of x and y coordinates. So divide both sides by what? By 5. Divide both sides by 5. You get what? 2 over 5 minus what? I over 5. Yes, then divide both sides by 5. And so that gives us what? 2 over 5 minus 1 over 5 I. So because 1 is the coefficient of I here. So if we want to represent this on the complex plane, let's say we have b into 2 over 5, that is for x, then y is minus 1 over 5. So on the complex plane here, now we go for x, we go for y. X is what? 2 over 5. No, 2 over 5 is less than 1. So x will be somewhere here. Let's say 2 over 5 is somewhere here. Fine. Then minus 1 over 5, that is what? That is y. Because it's y negative. So come down, let's say it's somewhere here. So this point, at the middle point of the two, so that's b 2 over 5 minus 1 over 5. So that is the representation of those values in the complex plane. Now, let's move further with another example. Let's move further with another example. Okay. Now, another example says, now this is talking about the modulus that I've explained before. Example 2. It says that if z is equals to 2 minus 3i, find the modulus of z. Like I've explained to you now, the modulus of z is what? Like I told you, compare this with what? Compare with z equals to x plus iy. So that implies what? X is equals to what? 2, yes, and y is equals to minus 3. Okay, and since the modulus of z is equal to the square root of what? X squared plus y squared. That implies, what is x now? 2 squared plus what is y? Minus 3 squared. Which is the same thing as what? In fact, it's the same thing with what I said before. And I just suggested that one before anyway. That question I solved before, plus what 9. Is still what? Root 13. Anyway, I never thought the example I gave you the other time would be the same thing as what I have here. So it's still what? 2 plus that is 9. This so it as what? Root 13. Suppose I have it, let's say 3 minus 4i. So that will not be the same example all true. Now, x will be what? 3 here. Well, what? Minus 4. Okay. Now, so 3 squared now. Then minus 4 squared. Okay. So that will not be the same example all true. Now, 3 squared is what? 9. Good. And minus 4 squared is what? Is 16. So when you add 9 to 16, you have 25. And what is square root of 25? That is 5. So that is that about that. Now let's solve this very funny question in complex number. This is a very funny one. You will see whether you understand what I mean by being funny now. Now, example 3. You understand why I said it's funny now. Evaluate the square root of minus 144 times the square root of minus 4 all over the square root of minus 36 times the square root of minus 9 all raised power 3x plus 5 is equals to 4 all over 3 raised power 20. 4 over 3 raised power 20. Find x. We are asked to find x here. We are asked to find x here. Okay. Now, without wasting our time, now recall. Let's recall that. Recall the square root of -1 in complex number is I. Therefore, the square root of -144 will be is like -1 times 144. Okay, we split that times -1 times 4. Okay, all over. I hope you are following. The square root of -1 times 36. Close it like this times -1 times 9. Good. Okay, so let's deal with this left hand side first. The another will be what? This is what? The square root of, if you split it now, you have the square root of -1 times square root of 1. Okay, let me continue here. Let me continue it here. By the time you split, you have what? The square root of -1 times the square root of 144 times the square root of -1 times the square root of 4 all over. I hope we are following. Good. The square root of -1 times the square root of 36. Yes. Then times. I hope you are following. Okay. I hope you are following. Beautiful. The square root of -1 times the square root of 9. Good. That is for this. If you split it now. So what is the square root of -1? I told you is I. So I times the square root of 144 is 12. So what? 12i times minus 1 is I, times the square root of 4. 2i, good. Yes, -1 is I, good, Abi? Yes, times this. 6i -1 is I, times this, that's what? Square root of 9 is 3i. So that will give us what? 24i squared all over 18i squared. I hope we get that. Fine. Now, let's not continue from there. Don't forget, we have only gotten this for this. We have not done any other thing. So I can clean it and later come back to that. Okay? So that implies 24 minus 1, because I squared is -1, all over 18 times -1, which is what? -24 all over -18. And this cancels this. We have what? What goes? 6 here, what? 4. 6 here, 3. Good. So that now means that the left-hand side, now is now equals to what? 4 all over 3. That is the old value in the bracket now. Raised power what? 3x plus 5 is equal to what? 4 all over 3 raised power 20. This has led us to what? Exponential equation. So now 4 over 3 as the base, 4 over 3 as the base. They cancel this each other out. So comparing the exponents, you have what? 3x plus 5 is equals to 20. So how do you now get x? Collect like terms. 3x is equals to what? 20. Take 5 to the other side. Minus 5. 3x is equals to what? 15. How do you get x? Divide both sides by what? 3. X now equals to what? 15 all over 3. So x is equals to 5. So the answer to this problem is x equals to 5. So if you are watching this video, probably you are joining us for the first time, subscribe to this channel, Dr. Oj Digital, and click the notification bell so that each time I upload a new video, you'll be duly informed. And if you have been our 100 subscribers, don't forget to always click like, share, and comment. God bless you. Bye.